Welcome back to my channel once again. Today we are going to talk about how the systematic of an Arduino is drawn from scratch in KiCad. So this Arduino is divided into different parts, which we have the DC power jack, the main microcontroller, the USB port, and the output pins. So to draw this, you need to pick the components one by one and connect wires. So that's what I have done over here. So after that, you need to check for the electrical rule to see that check for any errors inside. So as you can see, I'm done with the work. I'm done with the work. So I'm going to run my electrical rule check to see if there's any error or any mistake. So yeah, you want a resistor, you just type A to show for you to search for it. So this is the search bar, resistor. So this is a resistor. It's showing over here. Assign footprint. So you're supposed to know the particular footprint for it to show on the PC board, the SMD. So you need to choose. So as you can see, this is a hand soldering, not this one. So you can go for the SMD. So after choosing it, then you place it. Then you wire it. So this is how wire it. Connect wires. As you can see, I'm already done. So let me clean it. So let's run. For the first place, if you are done, then you annoy the circuit. So annoy the circuit. After annoy 0, 1 is 0 error. So we check the electrical rule checking. So this is the electrical rule checking. We are checking. So we run it. As we can see, we see 0 error, 0, 1 is, so which means the system is okay, no error. So now we drive straight to our PCB to do the routing and everything for the board to be prepared for manufacturing. Let's check the electrical rule checking to see if there's any error in the systematic or no. So the electrical, so let's run it. So as we run it, so 0, 1 is 0, which means there's no any error in the systematic. So let's continue our PCB layout. So this is my PCB. So if you don't add a correct footprint at the systematic, you don't get the actual layouts inside the PCB. So actually you can see these are my components. If you don't pick the correct one, you don't see the if you don't add the correct footprints, you don't see the actual components. So this my at Mega 328B. This my power jack, this my USB, this my key, this my memory. So if you don't, so the routing you need to follow all the air wires to route so that you get the correct distance. If you don't do it well, if you run your DC, the design root check, there will be error and there will be warnings. So you need to do every routing neatly to get no error. So as you can see, random, I'm done with every, so I'm not going to do anything to spoil it. So I'm just showing you how the routing. So if you want to route this placing of VIAC, so that you get front and back routing. So so this is how the Arduino board looks like. So I've designed it Arduino Uno. This is every measurement, everything is placed on it. Designed by Odikro Evans. So let's drive into the design root check. So the design root check, as you can see, we have 0 errors, 0 warning, which means our work is working perfectly. So let's move to the 3D. So as you can see, the 3D, this is a 3D designed by Odikro Evans, Arduino Uno. As you can see, you see the routing at the back, you see how it is looking perfectly. Yeah. So this is a board of Arduino. So let's come to the end of the design of Arduino from scratch, to the board, to the PCB layout, to the final board for manufacturing. Thank you. So as you can see, this is my design root check. I'm having 0 errors, 0 warnings, so which means the design tool is perfectly designed, no error inside. Okay. So as you can see, this is also the 3D model of the PCB. So it looks exactly like the Arduino board. So this the power jack, this is the USB. So this is my push button. This is my output pins. And this is a Atmega 328. As you can see, the bottle is working. The bottle is ready for manufacturing.